Hey, what's happening, guys? We are back working on the wireless weather station, and today we are going to build the rain detector. And for that, I've got some of this stuff here. Let's zoom in. This is Tapes Master 1/4 inch by 12 foot shielding conductive adhesive, and it is copper adhesive tape. So I'm going to put some strips of that on a PCB board, intertwine them like kind of the teeth on a comb, and, well, just watch. Alright, so let's hook up the meter probes to the wires. I'll get this to actually sit down here. There we go. And see if my theory is right. It's got a piece of bus wire on my finger for now. Well, it's not working so well. Let me put it out this way. It seems to be making intermittent contact. Which is strange. It should either make contact or not make contact. Alright, well, let's plug it into an Arduino and hook it up as a switch and try it with some water. Alright, so here's the Arduino. I've got the water sensor wired up with the 10K pull down resistor. And we've got a LED here on pin 13. So basically what happens is if we put 5 volts into D2, it should light up that LED. See what I do with everything else I was just using. Alright, let's move the Arduino over here a little bit. Bring in this bowl, bring these wires down here a little. Trying to get everything to fit neatly. And here we go. Here comes the rain. Hey, how about that? My water sensor works. Now, I realize that's copper, and it's going to tarnish and corrode over time. But that copper takes solder very nicely. So I can just tin the whole thing. Like I said, this was just a prototype to find out if my system was going to work. And it works. So I am quite happy with that. Now we can implement this water sensor into the outdoor wireless weather station. But hold on a second. Okay, for the display, I was planning on using this 2.8-inch color TFT touchscreen display that I ordered from Amazon. And it said it had the ILI 9385, whatever, the common driver is, and it could use the Adafruit library. Well, yeah, it doesn't. In fact, if we take a gander here, you can see the driver is the LGDP4535. So I had to search the internet high and low to find a driver for this, and I found one, and it still doesn't work. And I tried it with the Adafruit driver, and they said that if it comes up with unknown chip for the driver, then it's probably broken. But guess what? I think I found a way to fix it. Check this out. Okay guys, now that the TFT display has been properly dealt with, what I've done is just switched over to this Uno, and I'm using a Nokia 5110 for now, till I can get a new TFT in. And this time I did not order the bargain basement one. I ordered one from Adafruit, and after my last couple of experiences of ordering the really cheap stuff off of Amazon, I can honestly say I don't think it's any better than ordering the one hung low stuff from eBay. They're both made in the same place. Anyway, so it's all set up. Go on here. Now here is our transmitting unit, and there is my prototype rain sensor. You can see I have it hooked up here. Let's zoom in. It's hooked up here with the 10K pull down, coming over to digital pin 6. And I'm going to show you exactly how easy it was to add this. You're not going to believe. Changing the code takes about 2 minutes. So let's go look at the code, then we'll come back and check it out in action. Okay, I'm not going to go over the whole code again. I'm just going to go over the parts that we changed. This is the transmitter section. So what we have added here in the data structure, a Boolean variable called rain. And then down here in setup, pin mode 6 for input. And then down here in the function, read sensor, data.rain equals digital read 6. That's it. There's nothing else to do. Now for the receiver section, now it's going to look a little different because I had to add in all the crap for this Adafruit display. So we have SPI, Adafruit GFX, and Adafruit PCD8544. And then again here in our data structure we add the Boolean variable rain. We have setting up an instance of the display. Then here in setup we have all the do to set up the display. Down here in our main loop we do a clear display at the beginning of every loop. Now this is the old stuff where we printed it to the serial monitor. Now we begin the new stuff. Display set cursor is 0. Display print blah blah blah. Draw some boxes. I'm not going to go over all this with you. I'm just going to show you how simple it was to add this in. So we say if data.rain display print rain, else display print dry. That's it. So when you want to add a new thing to this, add a new variable in the structure package, access that variable, and print it out. That's it. Let's go check it out. All right, I am going to power up the transmitting unit. And we're good to go there. So I'm going to move it back out of the way here so that we can bring in the receiver. Now we already know that the range is good on these, so this demonstration is just to show you how the data and everything kind of works. Alright, so let's zoom in here. You can see the display. Where's my pointer? Alright, so we don't have much room on this display, so for right now it just says external condition. Temperature, which is actually in here in the lab, 71.6 degrees Fahrenheit. Relative humidity is 20% and dry. So now if I activate the rain sensor, it now says rain. And when there's no more rain, it goes back to dry. So that's where we are for right now. I was thinking of adding on this little guy right here. You zoom in, you can get a look at it. Maybe. There we go. This is the Adafruit UV sensor. So we could also have the UV index. This is an analog sensor. It just outputs a data. Really simple. So that's a possibility. But for now, that is it for the wireless weather station. Good, in my case, for a minimum of about 150 feet. If you guys are interested in me trying to find out how far it will really go, tell me in the comments. Give me a thumbs up if you liked it. Share. Make sure you subscribe. I'll see you next time. Thanks for watching.